So, hello everyone. Thanks for joining my talk today. My name is Pandy Knight, and I'm the Automation Panda. I came all the way from North Carolina to be here in Austin today, and I'm super glad to be here at Pi Texas. Fun story, you may know me as Pandy. My boy, Mason Egger, is the one who gave me that name. So I am currently a developer advocate at Applitools, where I help people get the most out of their test automation. Applitools provides automated visual testing tools. You can take snapshots of your website and mobile apps over time and detect differences visually. If you want to give it a try, please register an account for free and start running tests. I can help you get started. At Applitools, we also run Test Automation University, which provides free online courses for testing and automation topics. I've personally developed 4 courses for TAU, 3 of which cover Python testing. Definitely check it out. One of the toughest challenges in testing any software product is handling the test data. Now, when I say test data, I'm referring to multiple things. Test data includes both the actual data inside the product under test, as well as the data values used by test cases. As testers, we shouldn't underestimate the work to handle test data properly. Good data is just as important as good tests and good automation. In this talk, we will deep dive into the connection between product data and test case data. We will learn how to pick the right strategies for handling both, including how to avoid data collisions when testing. By the end, you'll know how to manage the test data nightmare for your own test projects, whether you're testing a Django app, a Flask app, some other Python project, or even something written in a completely different language. So, let's learn. Let's say we have an application for a bank to provide loans. The bank could configure this application for many different types of loans, such as a home mortgage, a car purchase, or even a student loan. All the information the bank needs to provide loans must be stored as data in the system. Each loan product is different. It comes with its own rate, maturity, and payment schedule. The bank must also store information about borrowers, funding curves, profitability targets, all this stuff. It's fairly complicated. Testing requires that all that data already be in the system as a prerequisite for testing. We could write a simple test case to exercise the basic application behavior. Like this scenario, create a new loan application. Given the Chrome browser is open, and the page myloanapp.com is loaded, when the user creates a new loan application for home mortgage, and the user enters all their personal information, and the user submits the application, then the page displays a success message with a reference number, and the loan application is sent to the bank. Now, bear in mind, a real loan application would probably need several pages of information, but let's keep our example today simple. This test creates and submits a new home mortgage loan application for the user. There are many test data points in this short scenario. Most apparently, all the user's personal info, the type of loan. There's also the record of the loan application sent to the bank, and the reference number shown to the user. Furthermore, that URL is configuration info, and the browser type is a test input. Test data is everywhere in this short, simple scenario. The data is inextricable from the test. Without specific data, this test would be meaningless. Unfortunately, the term test data itself is ambiguous. We've applied it to both the product data in the loan web app, as well as to various pieces of test case data that make even the most basic test work. Product data refers to real data living in the software system. For the loan web app, product data includes all the bank's product configurations and lending information. Test case data refers to data used to define test cases. It may include values to enter into the product under test, inputs to control how testing is performed, or records to retrieve the product. In the latter case, test case data is a reflection of product data. The two types of test data are separate, but nevertheless connected. Distinguishing these two types of test data is important to avoid confusion. The dependency of test case data on product data can be brittle. For example, consider our test case step to create a new loan application. to create a new loan application for a home mortgage. This step works as long as the bank's web app is configured for home mortgages. However, the product data could be changed at any time, just like product code. What if the specifics of a home mortgage application changed? What if the loan is no longer called a home mortgage, but a personal residential loan? That would make the test case break. Compounding breakages cause nightmares for test management. So, how should we manage test data? For feature testing, test data is just as important as test cases and test code. How do we handle both product data and test case data? Are there strategies we can use to avoid brittle dependencies? Okay. In this talk, we will explore multiple ways to handle both product data and test case data. Unfortunately, there are no universal or perfect solutions to the test data problem, but you can avoid nightmares by picking strategies that work well for your needs. Let's start with product data. As we stated previously, product data is any live data in the product or system under test. In simplest terms, it's everything in the database. Examples of product data include user accounts, administration settings, product customizations, records created by the user, and any files uploaded by the user. For our example loan application, product data would include the user accounts, the product settings, the loan applications, and the behind-the-scenes bank data. Data must be present in the product as a prerequisite for this kind of testing. There are two primary ways to get that data into your system. On one hand, you can set up the product data before running tests. This would be a static data creation method. For example, the loan web app could be set up with a set of pre-registered users and a collection of loan types. Test cases, whether they are manual or automated, can presume that the static data already exists in the application and simply reference it. Static data preparation is a great strategy for complicated data or data that is slow to create dynamically. For example, user accounts may need email verification, so it might be easier for automated tests to simply use a set of pre-registered users. Tests will run faster if they can simply reference existing data instead of creating new data each time. However, static data must be maintained. Any changes to static data could impact tests too. Static data may also become stale over time, as data formats are updated or if data is time sensitive. On the other hand, you can set up data during test execution. This would be dynamic data creation. In the example loan test case, the loan application document is dynamically created. This test does not reference any existing loan application. It creates a new one. Dynamically created records avoid the brittleness of hard references of static data. They can also be used exclusively by the current test case, protecting them from interruptions of other test cases, especially when running in parallel. The interruption, the main downside of dynamic data prep is the execution time. It slows down your tests. Dynamically created data is essentially disposable too, so eventually you ought to clean it up. Which strategy is best? Typically, testing requires both strategies together. Data that is slow to set up or considered immutable or non-changing should use static preparation, while data that is quick and easy to set up should use dynamic data preparation. When I develop test solutions, I prefer to create as much data as possible dynamically per test case to preserve test case independence. When a test creates the data it needs dynamically, it will be the only test using that data, so there is a much lower risk of collisions. These two data prep strategies are a bit complicated when implementing them. Dynamic prep depends directly upon the test case using it, but with static prep, there are a few general strategies that are independent of the test cases. Let's look at those. So, The simplest strategy for the simplest data prep strategy is manual configuration. That's exactly what it sounds like. Fingers on a keyboard. Testers log into the system and manually create whatever records they need in the system. They could be creating users, putting configuration settings in place, and saving records. Nice thing about this, anyone can do it. It's low tech. You don't need extra tools or fancy automation. However, manual configuration is slow, and it doesn't scale well for large systems or large teams. Furthermore, manually configured systems can easily fall into disrepair without any automated mechanisms for their maintenance. You're kind of stuck doing it yourself. Better strategy might be automated configuration. Woohoo! Automation Panda, right? Yeah. Rather than I'm sorry, this is a fun time. Rather than manually setting everything up, automated tools can create the desired data. This could be accomplished in many ways. You could reuse your UI interactions from testing. You could call REST APIs, even possibly using tools like Puppet or Chef. Automation could generate data deterministically or randomly. The main benefit of automation, is the ability to create fresh data at any time. Automation can also clean data, like scrubbing private fields or updating time-sensitive fields. Unfortunately, though, automated configuration is not a free lunch. It requires extra skills, and that code, just like your data, must be maintained. If you want a shortcut, you could try to clone the database. Cloning databases is easier than ever with cloud management tools. You can maintain one database in a golden state, and then create a copy before running each test. Once testing is complete, the copy could be destroyed. Granular cleanup wouldn't be necessary. Database clones make it easy to copy all data at once without worrying about any damage that rogue testing could do if it goes off the rails. But databases can have a lot of data. A lot of data. So maybe cloning isn't always that practical. It could take a very, very long time to dump a however many terabyte database. Clones also need extra refinement to scrub special fields and hook them up properly. Finally, if managing real data is too much of a hassle, you could mock your endpoints. This will completely remove dependencies on databases and even on live services. All data returned by the mocks would be deterministic as well, yielding consistent results. However, mocks are not always a good solution. They often require a lot of effort to set up, and mock data can make tests overlook unpredicted real-world variations. Mocks also mean that tests will not truly be end-to-end in their coverage. These strategies can also work together. They're not mutually exclusive. For example, you could use automated scripts to configure product data in a golden database, and then you could make clones of that database. In another example, let's say in a large test environment, you could choose to mock some endpoints while using real data for others. There are multiple factors that should be considered when deciding the best test strategies for static data prep. How big is the data? If it's small, then manual configuration is probably no big deal. But if it's large, you might want to be looking at some automated solutions. How fresh does the data need to be? Again, this goes back to that manual versus automated trade-off. If it is time sensitive and needs to be fresh, you're probably going to need automation to keep it up to date. How difficult will it be to try advanced tricks like mocking or cloning databases? This may be especially difficult for old legacy systems. Is there any bureaucracy in the way of automated solutions? Hey, I mean, it happens. Nothing is a free lunch. Not every organization has an efficient or even healthy culture. Bureaucracy can stonewall advanced solutions that need extra support. Do folks have the skills required for automation, database administration, or mocks? Skill level may be a barrier at first, but training and learning can help overcome any limitations here. If you need help with that, again, Test Automation University. And finally, what about the cost? Each data prep strategy has a cost. Teams should do a cost-benefit analysis when deciding what strategy to take. So, that's product data. What about test case data, that other half? Let's look at that next. Test case data is inherently part of test cases. Let's revisit our example test case from earlier. As we saw before, there are multiple bits of test data throughout the steps of this short scenario. They represent different types of test case data. First, let's look at that first step, given the Chrome browser is open. The Chrome browser is test data because it specifies what type of browser in which to load our application under test. This is what we call a test control input. It directs how tests will be run rather than specifying any sort of feature behavior. Theoretically, this test should run the same on any browser. But the steps that dictate that these steps dictate that the test should run in Chrome. As a best practice, test control inputs should not be hard-coded into your test automation. Don't do that, please. Instead, they should be passed into automation as inputs. That way, tests can easily be retargeted. There are a few ways to do this. Simplest way would be to create a flat file with input values. I recommend using a format like JSON or YAML because they're easy to write, easy to read, and easy for programming languages to parse. In fact, in Python, JSON is part of the standard library. It can also have line-by-line diffs. Test automation code can read the file before any tests start, and it can inject these input values as appropriate, using something like, let's say, a PyTest fixture. For example, using this JSON file, automation could read the browser, construct a Selenium WebDriver object, or if you're using Playwright, pick that browser, and inject that into each test. The path for the input file would need to be hard-coded into your automation code, but it could be as simple as a standard file name in your current directory, like inputs.json. Another way to handle inputs is using environment variables. Testers could set variables from a system shell or profile, and automation could read those variables by name. This can be very useful for integrations with continuous integration servers like Jenkins or even Docker containers. However, it can be a little more dangerous because anyone could change the variable values. Again, automation can read these variables in and handle them as appropriate. So let's remove that hard-coded step for browser type from our test scenario. That can be handled as an automation level concern. Next, let's look at a second type of test case data. Notice how this URL is hard-coded, myloanapp.com. Typically, development teams host multiple instances of products under development, like a developer environment, or a staging environment, or a test environment. Hard-coding configuration information like this limits where tests can run, just in the same way that browser dictation did. Any information about a product's configuration is called configuration metadata. This includes things like URLs, usernames, passwords, and possibly other descriptors. There's a few ways to handle config metadata. You can use flat files or environment variables, like for test control inputs. However, I personally recommend using flat files, and also recommend separating test control inputs from configuration metadata. Create an input to refer to a target configuration, and then store multiple configurations in config metadata files. That way, testers can change just a few simple inputs to target any configuration. And they won't need to change multiple configuration fields regularly. If you want to be fancy, you could create like a web service or something to provide config metadata, which could be especially helpful for keeping secrets like passwords safe. But creating such an endpoint may be overkill for your needs. Either way, the test case step can be rewritten to refer more generically to the web application rather than a URL. Automation can select the target environment using inputs and config metadata. The remaining pieces of test case data all fall into a category called test case values. These values pertain directly to the behavior exercised by the test, not to any configuration factor. Even in this classification, there are subtypes. First type of test case data is what we call a literal value. These are values that are hard-coded into the test. In this example, the table of personal information contains literal values. Literals are simple to use, and they provide specification by example. Literals should also be independent of any statically created product data. They should be values that can be safely originated by the test case. The literals in this info table will be entered as input values into our web application forms. Theoretically, these could be any values. Shouldn't matter. The second type of test case values are what we call output references. These are values that are retrieved from the product under test. Typically, they are the outputs generated by exercising product behaviors. In this test example, the reference number can be scraped from a success page and verified for correct formats. The loan application can be retrieved from the web app's backend to verify that it was created successfully. These values cannot be literals because they originate from the product. Tests must refer to them by reference and retrieve their values from the product. As a side note, this test dynamically creates the loan application. Right here is an example of that dynamic product data preparation that we covered earlier. The third and final kind of test case value is the trickiest, the input reference. At first, these may look like literals. However, input references are values that directly refer to product data. While personal info like your name and address can be created dynamically by the test case, the name of the loan type refers to the loan configuration in the web app. Thus, this test has an input dependency. It must specify the type of loan, and that type of loan must already exist in your product data. The simplest way to write this test is to simply hardcode the reference. That's what we did here. The name home mortgage is some sort of identifier or pointer that refers to the name of the loan type in your web app. Automation can use that name when selecting the loan type from a button or dropdown. Hard-coded references make it easy to write tests, but they require statically prepped data to exist in your system already. References also become hard to maintain when the product data changes, or when the same test must run against different configurations with different names. One way to avoid the pain of static data is to dynamically create these records or configurations. If the test calls the backend to create a new loan product named home mortgage for each test run, then static pre-prep isn't needed. However, we already know the pain points of dynamic prep. It can be slow. In this case, let's say dynamically creating a whole new loan type in your application is just too much work. A more robust solution could be what we would call data discovery. Let's say the target web app is already configured with multiple acceptable loan types. Instead of hard-coding the name of the desired loan type, this test could describe the loan type and then use automation to search the web app's configuration for the desired criteria. For example, if different regions of the bank have different names for this type of loan, the discovery mechanism could look into the config for a satisfactory home mortgage-like loan and return that as the name or pointer for your current bank region. Discovery enables tests to search existing product data for required records instead of hard-coding those records. Discovery makes tests more resilient to change in product data. It's great when testing multiple environments with ever so slightly different configuration values. However, it does require extra coding, and again, this may be overkill for your needs. So, that's a lot of information about test case data. Is everybody with me? Cool, awesome. So, in summary, test control inputs direct how tests will be run, not what behavior is covered. They should be supplied via flat files or environment variables. Configuration metadata describe product configuration for the target environment. They should be supplied via config files or some sort of service API. And test case values direct behavior covered by the test. They may be literals, output references, or input references. And input references may be hard-coded or discovered. At this point, you're thinking, okay, we got 5 minutes left in this talk, right? We've covered a lot. Geez, that's a ton of information, but that's it, right? We're done. We can move on to Q&A and take a break. Well, frightfully, nightmare's not over yet. There's one more problem to address. Collisions. Collisions can happen whenever multiple actors operate on a shared resource. What does that mean in layman's terms? This thing has it, and this thing also wants it. That's a collision. For example, they could happen when multiple testers simultaneously access the system, or especially when your tests run in parallel. You got to take additional considerations to avoid collisions. First and foremost, isolate your test environment. As much as possible, please isolate your test environments. Prevent external actors from interrupting your tests. If you have a shared test environment, block other folks from accessing the system when tests are running. You might need to schedule tests during off hours, like overnight. You may also want to set up multiple test environments. If the product under test is containerized, or if your database is clonable, you're in luck because then you can easily dynamically create fresh environments on the fly for each test run. That would guarantee perfect isolation. Secondly, treat any shared data as immutable, meaning unchanging, meaning you don't go in and twiddle with it. Sometimes shared product data is unavoidable. I've lived this myself. If tests run in parallel against one test environment, then you're at risk of sharing that product data. Or if an application has multiple components, certain components may be difficult to isolate for testing. Whenever data must be shared, treat that data as constant, as immutable. Any changes to shared data could break tests. For example, one test might require a car loan, or the other test deletes it. Oops. Don't let that happen to you. Third and finally, use dynamic data preparation as much as possible. Tests can't collide on data they don't share. Keep statically prepared product data to a minimum. Statically created data is more likely to become shared data, and shared data is more likely to cause collisions. So, boom, we made it. We covered a lot of good stuff in this half hour. So let's quickly recap what we learned. There's two primary data types for test data, product data and test case data. Product data can be prepared statically or dynamically. Test case data either control how tests run or reflect product data. Handle references and shared data carefully. And overall, the main point I want you to walk away with today: choose the best strategy to defeat your nightmares. Every product is different, every team is different. Take the strategies I shared in this talk as suggestions to help you do what you got to do. So, thank you all very much for listening to my talk today. Again, I'm Pandy Knight, and I'm the Automation Panda. Be sure to hit me up on Twitter, and if you want to get some Panda stickers after this talk, please let me know. I got a ton of them. Have fun with PyTexas. It's good to be here.